Hello, my eighth graders, and welcome back to another lesson with me, Damian Anderson. So before I get started here, let me explain myself first. And of course, I got a new setup here. But besides that, um, me and Angie, we have not been on lately of uploading new math sessions with you guys and here's why. We wanted you all to catch up on any lessons that we have taught you guys. We just uploaded. All of our lessons are uploaded now onto our YouTube channel, Future Educators Talk, under the playlist Math Virtual Learning Session, to where all of our lessons are there. So you could catch up on any lessons that we have taught you guys. Andrew, he's teaching sixth graders. I am doing eighth graders, and any other grade levels that needs our help, please contact us and we'll be gladly to help you. So your students can succeed, can excel into their math classes this school year. Okay, so let's get started here. We are still my eighth graders, hello. And also sixth graders, if you're watching this, pay attention as well. But we are still dealing with solving equations. We are still doing that. The last time that I was on doing a lesson, I showed you guys probably 3 or 4 YouTube videos of this lesson here. And then I said that the next time I was going to show you guys, I had one more video to show you guys, and then I had some notes. So I'm going to do that today. And then right after that, I have another lesson dealing with equations, but it's going to be equations with parentheses. All right. So let's get started here with this last YouTube video that I have for you guys. So let me share my screen right now. And as you can see, our last YouTube video is equation with the variable and the denominator. You can see the variable, which is x, it is in the denominator, okay? And whatever on top, that is your what? Your numerator. So write that down, remember that, please. Okay, so we're going to be dealing with this. We need to break it down, how we're going to solve it, all that good stuff. So let me put it to full screen, and then I'm going to minimize myself. I'm going to hide myself so you guys can see all the work that he is going to be doing for you guys. And of course, I'll be back with more. And plus, I'm going to be stopping it here and there just to explain it. So let me hide myself now, and let's begin. And pay attention, have your notebooks and pencil stuff out. Here we go.
So I have the equation 7 minus 10 over x is equal to 2 plus 15 over x. And so this isn't the type of equation that you might think that you're used to solving, but I'll give you a few moments to see if you can solve it on your own.
And we're not going to do that.
Both sides to actually simplify this to a form that we are more used to looking at. So what's probably bothering you, because it's bothering me, is these x's that we have in the denominators right over here. We're like, well, how do we deal with that? Well, whenever we see an x in the denominator, the temptation is to multiply it by x. But we can't just multiply one of the terms by x. We have to multiply the entire side by x.
Exactly. And that is where some of you students get mixed up at. You do it to one side, but you don't do it to the other side. And that would mess you up with the entire problem because you are getting it incorrect. When you're doing this, whatever you do to one side, you have to do it to the other side. You have to, because if not, you're going to mess up with the problem and you're going to get the answer incorrectly. Okay? So whatever you do to one side, do it to the other. Remember that, write it down, remember it. Here we go now.
So we could multiply this entire side by x, but we can't just multiply the left-hand side by x. We'd also want to multiply the right-hand side by x. And so what will that give us? Well, we distribute the x. We get x times 7 is 7x. And then x times negative 10 over x, well, that's just going to be negative 10.
Correct.
So you get negative 10 right over there. So the left-hand side simplifies to 7x minus 10.
So there's your one equation right there. I'm going to give you guys time to figure out what will the next equation be. What's going to be the second? He already did the first one, but I want you guys, before I begin, what's going to be the next? What's going to be the next equation? I'm going to give you guys time to see. So take some time and figure this out. What's the next equation going to be? All right, let's see. Did you get it correct?
And then your right-hand side, once again, distribute the x. X times 2 is 2x. X times 15 over x. Well, x times something over x is just going to be the something. X times 15 over x is just going to be 15 plus 15. So now,
did you get that? Did you get that for your second equation, 2x plus 15? I don't know because I can't see, but hopefully you got it. Hopefully you got it. All right, let's continue now. We are back to a two-step equation from what we did the last time that I was on. And we need to break it down into one equation, and we need to get x by itself. Now, as I mentioned last time, there are 4 ways that you can break this down, and you're still going to get the exact same answer each time. Okay? Now, let's see what he's going to do with this. Okay?
now we've simplified this to a linear equation. We have...
Oh, yes, this is, I forgot to mention, you guys, this is a linear equation. I forgot to mention that when I first introduced equations. This is a linear equation. Probably some of you guys already knew that, some of you guys probably didn't, but this is a linear equation. And what is a linear equation, you might be asking? Well, I will tell you guys what is a linear equation. So pay attention. Okay, so here is a linear equation with a definition of a linear equation. And I apologize, you guys, you probably are hearing some noise in the background, a baby. I apologize in advance. But what is a linear equation? And write this down here. I wish I could, let's see, I could probably write it down for you guys right here. Yes, I can. Okay, so let me write this here. What, and let me do this in black. Okay, so what is a linear equation? Well, here's what a linear equation is. It is an equation between 2 variables that gives a straight line when plotted on a graph. Okay, so that is what a linear equation is. Okay, and also an example of a linear equation. Well, here's the how would you say, here's the formula for, I'm gonna put this, let me change it. Here's the formula for a linear equation. Y equals mx plus b. I don't know, you guys are familiar with that, you never heard of it. Well, that is a linear equation. The formula, y equals mx plus b. Okay, so in this problem here, right here, your mx, this is your slope. Okay, your mx, let me put this down here. Your mx, that is your slope. Okay, then your b, that is your y-intercept. Okay, so in this problem right here, your 7x, that is your slope. This equation right here, your 2, that is your slope. The -10, this is your y-intercept when you're going to plot this onto a graph, which I will show you guys later down the road, probably in a couple more lessons. And then your 15, that is also your y-intercept as well. So copy this down here, copy these down. And let me try to, it's probably going to, yeah, it's going to do the exact, okay. So copy this down here, copy. I'm gonna put it here because I don't know if I can keep that up here, but I'm gonna shrink it down. Well, hold on. Hold on, you guys. Okay. I'm just experiencing you guys. Okay. Now, let me put this, I'm gonna keep this down here and hopefully it will probably stay throughout. So if you didn't copy this down, it's still gonna be up here while you guys are finishing up this video. So let's see what he's going to do here. Okay. Oh, and it went away. Okay. And I can't get it back. Well, hopefully you guys wrote it down. Okay, let's continue on.
The variable on both sides, so we just have to do some of the techniques that we already know. So the first thing that I like to do is maybe get all my x's on the left-hand side. So I want to get rid of this 2x right over here, so I subtract 2x from the right-hand side.
Okay.
Now, and
you could do it either way you want to. Either way you want to. You do not have to do what he is doing, but if you feel comfortable doing it that way, you can. But you could also do take away 7, get it by itself. Get rid of it. Subtract 7x. Subtract minus 7x here, minus 7x here. You could add 10 here, add 10 here. Of course, subtract 2x, or subtract 15, subtract 15. Either way, you guys, either way, you're still gonna get the exact same answer, okay?
Please remind you, I can't do that just to the left, just to the right-hand side. If I did just to the right-hand side, it wouldn't be an equality anymore. You have to do that to the left-hand side as well. And so we are left with, let me get that pink color again. The left-hand side, 7x, 7 of something minus 2 of something, where you're going to have 5 of that something, minus 10. These two x's negate each other, and you're left with equals 15. Now we can get rid of this negative 10 by adding 10 to both sides. I like that green color when I do stuff to both sides. So I can add 10 to both sides, and I am left with 5x, these negate each other, is equal to 25. And this is the home stretch. You see where this is going. You can divide both sides by 5.
You guys should know what this is.
And we are left with x is equal to 5. Now let's verify that.
Bam, bam, bam. That is your answer. That is your answer. If you did it this way or any other way, you should get 5. If not, if you did not get 5, check back. Check back. You did something wrong, so check back. Okay? Now, he is going to check his work to see that he did it correctly. And I want you guys to do the exact same thing as well, and to all of your problems as well. So, here we go.
This actually worked. So let's go back to the original equation. We have 7 minus 10 over 5. This needs to be equal to, I'm just taking our 5 and substituting it back here. This needs to be equal to 2 plus 15 over 5. So this is 7 minus 10 over 5. This is just 2. Needs to be equal to 2 plus 15 over 5, which is just 3. So 2 plus 3. 7 minus 2 is 5. 2 plus 3 is 5. 5 is indeed equal to 5. And we are
Bam,
done.
bam, 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 bam. That means you did it correctly. You did it correctly. Okay. So copy this down here, and we are finished with this YouTube video here. And I'm going to show you guys some notes, some basic, simple notes of equations that I have here. And these notes, I check back, you guys, these are correct. Okay. And I will get back to the scientific notation, but not at this moment, okay? Because I want to get all the stuff in that you guys are learning right now, get that in as possible. And then I will go back to the other that you guys have already learned at the beginning of the school year. Okay, so copy this down here, take a screenshot of this. I know you guys are watching this on our YouTube channel, so take a screenshot of this or write it down quickly, and we will dive into our notes, okay? All right, hopefully you got this copy down, and now I'm going to stop the share right now. Okay, and I need to scoot back a little bit. Okay, so now we're going to dive right, okay. Now we are going to dive right into some notes that I have. The first set of notes which I have is solving equations, of course. And then the next equation is creating and solving equations. So we're going to look into that. How can you create an equation from word problems, of course. So let's begin with our first set of notes, which is solving equations. So let me share my screen. And here we go. All right. And let me put this to full screen to where, okay. Now, solving equations. So you have here this is our I can statement. I can construct a convincing argument that justifies each step of solving an equation. Okay, so let's dive right into it. Now, some of you guys are wondering, what is an equation? Well, here is what an equation is. Okay. The definition, here's the definition of an equation, which is a math sentence that shows two values are equal. Highlight, let me do it up here. That shows two values are equal to each other, okay? And then you also have, it is a solution of an equation, is the value for a variable that makes the equation true, okay? That makes it true. So an equation is a math sentence that shows two values, they are equal to each other, and also a solution of an equation is the value for a variable that makes the equation true, okay? Now, copy this down here, and then I have some examples of an equation. And you guys already know what an equation looks like. So once you copy this down, here's your first example of an equation. So write this down here. 3x minus 2 equals 6, and I have it down right here, you guys. I have it down right here, but I broke it down and I have the answers to it. So I'm gonna show you guys that in a minute. So I'm just gonna be speaking. 3x minus 2 equals 6. So this is a one equation here. Now, what am I going to do to this equation here? I gotta get x by itself. So what do I need to do? Well, 3x minus 2 equals 6. I got to get x by itself. So I got to add 2 on both sides. So you're going to add 2 on under the negative 2 and also under the 6. Okay? So negative 2 plus 2, that equals 0, so that crosses out. So bring down your 3, 3x equals, then you have 6 plus 2. Well, 6 plus 2 equals what? Is 8. So you bring down your 8. So you have 3x equals 8. Okay? Now, we're good to go. We're good to go. We're good to go. Now, the only thing that we need to do, of course, we got to get x by itself. Now, the simple way, well, of course, is you got to break it down. We got to divide by what? 3 on both sides to get x alone. So divide by 3 on both sides. So it's going to be 3x divided by 3 equals 8 divided by 3. So what's 3x divided by 3? Now that crosses out, so you're left with x. So x equals, and then 8 divided by 3, that gives us a decimal. And that excuse me, guys, and that decimal is 2.666666667. Okay, repeating decimal. So you could just leave it as 8 over 3, 8 third, 8 3, whatever, however you want to say it. So that is your answer. 3x minus 2 equals 6. That gives me x equals 8 over 3. Okay, now let me show you guys. Let me show you guys the steps of how I did it. Okay, so, and I'm going to scroll down now. I'm going to leave this up here, the definition. Let me scroll down. Okay, so you have 3x plus 2. That's supposed to be... Oh my gosh. Hold on, you guys. Okay. Okay, let me change this very quickly. It's supposed to be 3x minus 2 equals 6. And I have 3x plus 2 equals 6. So let me change that quickly here. Okay. Okay. Now, of course, this, you're adding. There we go. Now, as you can see right here, I broke it down into steps of how you're supposed to do this. You got 3x minus 2 equals 6. Well, what I did here, I add 2 onto both sides, we got to break down 3x. So what I did here is the addition property here. Then next, I brought everything down. Brought down your 3x. Negative 2 plus 2 is 0. So you don't have to worry about that. Bring down your equal signs. And 6 plus 2 is 8. So I brought down the 8. And this is where you combine like terms. Then what I did is I got to get x by itself. So I divided by 3 on both sides, which is I did the division property. So 3x minus 3, 3x minus 3. 3x divided by 3 is just 1, so it's x. So x equals, then 8 divided by 3 gives me 2.666, it's a repeating decimal. So it's 8 over third. So I simplified the answer. And that is how you do it. Okay? Now, let's go on to our next set of example. Okay? I have, and I'm just going to bring all this down here, get rid of the x. You guys, here I go again. Okay. Okay, okay, there. I'm trying to press the X button. Okay, so our next example is 1/2 y plus 4 equals 10. And in these two examples, you guys, this is in the formula of y equals mx plus b. Am I right? Yes, I'm right. So what did I did down here? You guys are wondering. Well, you have 1/2 y plus 4 equals 10. So, and what I need to do here is get 1/2 y, I gotta bring that down, get y by itself, of course. So what do I need to do? Well, I need to subtract 4 on both sides. So subtract 4 under the positive 4 and then under 10. So so I have to bring down y/2 y. Plus, now what's 4 minus 4? Just give me 0, so you don't have to worry about that. So 10 minus 4 is what? 6. So bring that down. So you have 1/2 y equals 6. Now, here, and then of course here I did the subtraction property here when I subtracted. Now, the next, here's where, if you guys remember from that last video that I showed you guys, the opposite of division is what? Multiplication. So I'm going to have to multiply whatever I have in the denominator, which is 2. So multiply 2 on with the 1/2. And whenever I do to one side, I have to do the other side. So I got to carry the 2 right beside the 6. So now I have 2 times 1/2. So what does that give me? It just gives me 1, it just gives me y. So y equals 6 times 2 is what? 12. So our answer is 12. Y equals 12. And what I did here, if you guys can't see that, this is the multiplication property. Okay. Now, I also have some more examples, but I'm just going to let you guys copy those down because these examples are pretty much simple. So copy this down here and let me move on to where you guys can take a screenshot of it because I'm going to move very quickly so I can get on to my next set of notes and one more video to show you guys. So copy this down here and I'm going to the next screen, now. Okay, and let me just get rid of this X here and copy all this down here. Okay, copy, copy, copy. Every step. Or take a screenshot. And this is right here, this is 4A, not 49, okay? This is 4A. As you could, if you read up here, that's 4A. So this is not 49. No, it looks like a 49, but it's 4A, okay? All right, moving on to the next screen. Let me exit this out. If you didn't copy it down, well, you will copy it down. You will get it if you just go back. Just go back to it. And copy this down here. Copy, copy. All right. And I believe this is it. So I'm going to stop. Hold on, you guys. Sorry. Okay, I'm going to stop the share right now. If you didn't copy this down, you can always go back to it. So I'm going to stop the share now. And let's dive right into our next set of notes, which is creating, and solving equations, okay? So let's get into the fun of that. Creating and solving equations. Here we go. Of course, let me put this to full screen. Ooh, come on. All right, creating and solving equations. So our I can statement is, I can create equations and use them to solve problems. Which is word problems, okay? I should have put that there. I can create equations and use them to solve word problems. So let's dive right, before we dive into our first word problems, I have some, what would you call this here? Maybe terms to copy down. So yeah, okay. So our first is, and let me, okay. Yeah, okay. So our first word phrases for equations, what you guys need to look out for is equal to and is. So look out for those in equations, into your equations. Word phrases for equation. Okay. So here's the first example that I have. The sum of 14 and a number is equal to 17. Now, what word phrases do you see that points out to you? Well, you see sum, and I forgot to circle that. So you see sum, and then you also see is equal to. So you have sum, you got sum, well, it's fine. Sum, we'll just circle that, you guys. Sum won't let me mark. And is equal to. So when we break this down, the sum of 14. So the sum of 14. So also you're going to bring down 14. So what does sum means? Well, sum means addition. So 14 plus the sum of 14 and a number. So 14 plus x. It says any number. It could be any number. Any number. Is equal to 17. So 14 plus x equals 17. That is your answer, ladies and gentlemen. 14 plus x equals 17. When you break it down, because you have the sum of 14, which is 14 plus, and a number, which is x, is equal to, you have the equal sign, 17. Then you have 17. All right, let's look at one more. Oops. 2/3, a number, plus 4 is 7. So you have 2/3. So bring that down. 2/3, a number, is going to be 2/3 x, correct? Correct. Plus 4. So bring down your plus sign. So you got 2/3 x plus 4 is, what this is, what this is, what is, I don't know how another way to say it, but that is your equal sign. So bring down equals, so 2/3 x plus 4 equals, you have 7. So bring down your 7. So, ladies and gentlemen, your answer is 2/3 x plus 4 is 7. Voila, there you have it. All right, you guys copy those down. And we're going to move on. We're going to move to our first word problem. Boom. Sorry, you guys. You could probably hear me crunching because I'm eating snacks at the moment. So I'm so sorry. I should mute myself doing this. But it's fine. All right. Let's move on to our first word problem, okay? So, and I got to, okay. Well, right before, let me read it to you guys first because I believe that I will, of course, I'll mark all over the problem. So listen to this and write it down too. I'm trying to read this slowly as possible to where you guys can copy it down. Each of their tickets, here goes. Each of their tickets cost the same amount. Each of their tickets, I'm gonna repeat this 3 times, you guys. Each of their tickets cost the same amount. Each of their tickets cost the same amount. One more time. Each of their tickets cost the same amount. Tickets, you guys. Each of their tickets cost the same amount. And they share a frozen yogurt. And they share a frozen yogurt. One more time. And they share a frozen yogurt that costs $5.50. That costs $5.50. And put a period. Here's your next sentence. I feel like I'm an English teacher. The total amount they spend is $19.90. The total amount they spend is $19.90. All right, so let's look into this equation. Let's look into this word problem to break it down to an equation. Let's look at some word phrases we catch. All right, so what do you see here? Let's go back and reread. Each of their tickets cost the same amount, and they share a frozen yogurt that costs $5.50. Okay, you guys need to underline that because that is important. That is part of our equation. Okay. Now, into our next sentence, you have the total amount they spend is $19.90. Underline $19.90 because that is our next equation. Now, if we go back, total. That is a word phrase. Am I right? Yes. So what is total? Circle total. What is total? If you guys remember back to when Andrew, he gave out some word phrases. And also to me as well, a couple of lessons back, what is total? Total is addition, correct? So under, put an arrow and put a plus sign because that means we're going to add. Okay, so the total amount they spend is, there's that word is, which means equal sign. So put an equal sign there. Now, we have our first, and let me write this down here to where you guys can see. Okay, here we go. So I did the exact same thing as well. This is for visual learners who needs to see. All right, so let's break this down here. So we have the cost of a ticket. Well, that is going to be C because we don't know what's the cost of tickets, correct? We don't know. So if we break this down here, here's our equation, ladies and gentlemen. 2C plus 5.50 equals 19.90. Now, some of you guys are wondering, where did I get the 2 from? Well, if you go back to the problem, each of their tickets cost the same amount. Each same amount. Each same amount. And they share frozen yogurt. Well, that's not important there. Well, it quite is. But each of their tickets cost the same amount. Each. Each means what? 2 together. So you got 2C plus $5.50 equals $19.90. Now, I did not work this out, but if I did, here's what our answer is going to be. And I'm going to bring this up because I don't have room at the bottom. I got another problem. So let me move this. Ooh. Let's undo that. So let me bring this up here. That should give me enough. Okay. So what do I need to do to get 2C or to get C by itself? Well, I got to subtract. I got to. So what do I need to subtract? 5.50 or 19.90? Well, I guess that I have to subtract 550. Am I correct? So you're going to subtract 550 on both sides. Sorry guys, my handwriting. Okay, so you're going to obviously bring down your 2C. 2C. Now what's 5.50 minus 5.50? Nothing. It just gives me 0. So you're going to bring down your equal sign. Equals what's 19.90 minus 5.50? It gets me 14.40. Now, this is where I like it here. Okay, so I got to get rid it. I got to get it by itself. So what do I need to do here? Subtract 2 on both sides. Whatever I do to this side, I have to do it to the other. So 2C divided by 2, it just gives me 1. So you're going to break down your C equals 14.40 divided by 2 gets me 7.20. So what you're going to have left is $7.20. If it asks how much, if I finish out the problem, how much do you have left over? So there you have it. Okay, let me move on to our next problem here. And I wish Andrew was here to see this because he's probably going to really like this here. So I'm going to read it out. So pay attention. Damian and Andrew are bowling. Damian and Andrew are bowling. Andrew's score is twice the difference of Damian's score and 5. Andrew's score is twice the difference of Damian's score and 5. The sum of their scores is 320. The sum of their scores is 320. Find each of their bowling scores. Find each of their bowling scores. So let's look into this equation. Why do I keep saying that? Let's look into this problem here, this word problem, and let's look for some clues, some word phrases. Let's look at them. So if we go back, Damian and Andrew are bowling. Andrew's score is twice. Twice. That sounds familiar. Twice. What does twice means? I feel like I'm talking to you guys like in real time, but I'm not. You guys are not actually here. But what does twice mean? Well, if I recall back in high school and middle school, twice means multiplication. You have to multiply. So put an arrow to that and put an X sign, or you can write down multiply, whatever. Okay. So Andrew's score is twice the difference of pause. Difference of, you guys should know this automatically. Difference of means what? The difference you're going to have to take away. You're going to have to subtract. So put an arrow to that means take away or subtract. So Andrew's score is twice the difference of Damian's score and 5. I want you guys to underline Damian's score and 5 because we will use that. The sum of their scores, pause. The sum. Did we do that earlier? Sum? Did we do that earlier? Yes, we did. Yes, we did. If you go back, what do we use for sum? Addition. So put an arrow to that, meaning addition. The sum of their scores is, pause again. Did we use that already? Is? You guys should already automatically know which is what? Equal to. So put an equal sign. Is equal to 320. Find each of their bowling scores. So let me to where you guys can see the lovely work. Oops, I did. So Damian and Andrew are bowling. Andrew's score is twice the difference of Damian's score and 5. The sum of their scores is 320. Find each of their bowling scores. And you can see I underline twice and I put a multiplication sign. I underline difference of Damian's score and 5, which means subtract, take away. Then I circle sums, which means addition. Then is, which is your equal sign. So let's break this down here. Damian and Andrew. That is this is our bowling score, you guys. The sum of our scores, if you go back, the sum of our scores is 320. So that is what we came up with all together. Okay. Now, I wish, hold on. Oh, yes, I can. Yes, I can. Yes, I can. Okay. Oh, never mind. Okay. Now, if we go down, I'll break this down. Let's go to my bowling score. So I have x equals to something because we are trying to find out what did I get? Okay, what is my score? Okay, then we already know what's Andrew. We have Andrew, you got 2 times x minus 5. Where in the world did I get the 2 from? Go back and read the problem. Andrew's score is twice. Twice means what? 2 times. So 2 times the difference of my score and 5. So x minus 5. Okay? So we need to find out what is my score. What is it? Well, I will tell you guys. Here's our equation. X plus 2 times x minus 5 equals 320. So that is our equation. That is how you set up the equation. Where did I get this? Where did I get this equation from? I got it from here, ladies and gentlemen. Got it from there. X plus 2 times x minus 5 equals 320. And then 320, which was up there. Okay. So we need to find out what is my score. Now, as you can see here, well, some of you guys are wondering, what do I need to do? Well, you can see here, I distribute. I'll start with that first. I distribute 2 into x and 2 into negative 5. So you're going to break it down. X plus, what's 2 times x? Is 2x. So you have x plus 2x. Then 2 times negative 5 is minus 10. Negative 10. So you have x plus 2 minus 10 equals 320. And if you guys need to see it, there I have it. X plus 2x minus 10 equals 320. Now, I have some like terms. I got x and I got 2x. So I need to combine those together to get only one x. We only need one set of x. So what's x plus 2x? It gives me 3x. So you got 3x minus 10 equals 320. You're going to bring everything down. Bring everything down. And put an arrow here. Bring everything down. I wish I could bring it down. Gonna bring it down. Bring it down. So you got 3x minus 10 equals 320. And this, ladies and gentlemen, is in the format of y equals mx plus b. Am I right? Yes. Yes. Now, what do I need to do here? Well, simple. I need to get x by itself. So I have to add 10 to both sides. So you're going to automatically bring down your 3x. 3x, what's negative 10 plus 10 gets me 0. So you have 3x equals 320 plus 10 is what? 330. So you got 3x equals 330. Let me show you guys. Bam. Okay. Now from here, I got to get x by itself. So I got to divide by 3 on both sides. That crosses out, you guys. So I got to get x by itself. So divide by 3 on both sides. So what's 3x minus 3? Why do I keep saying that? What's 3x divided by 3? It's just 1. So you have x equals, then 330 divided by 3 gets me what? Ladies and gentlemen, students, 8th graders, 110 exactly. Oops. So here you go. Automatically crosses out. And here's our answer. But wait, this is my score. This is what I got. This is my score, 110. Okay. Now, we need to figure out what Andrew's score, what did he get? Because I got 110. So we need to figure out what his score is. Well, how in the world are we going to figure out what his score is? Well, ladies and gentlemen, if we go, okay, so copy all this down here first, and then I'm going to move on. Well, how in the world, let me move on. No, that's, like, this is probably something else. Yes, okay. So let me go back. I could do it down here. So how in the world are we supposed to figure out what's Andrew's score? How is that? Let me have some more room. Okay, so if we go back to what Andrew's score was, okay, Andrew, we have 2 into x minus 5, correct? Correct. Let me bring this down some more. Okay. So, my score was what? 110. That was x. You see where x is? We're going to plug in my score into x to get Andrew's score. Okay? So, I had 110. That was mine. 110. Okay? So, 2 times, what was mine? 110 minus 5. Okay? Now, we got to work if we, do order operations. What comes first? You have your parentheses. So that's what we have here. So into our parentheses, we have 110 minus 5. Well, what's 110 minus 5? 105. So 105, bring it down, 105. Still have your parentheses because we're multiplying here. Now, what's 2 times 105? You got it. It's 210. So this is his score. Sorry guys, this is all sloppy looking. So that is his score, 210. And if we combine those together, 110 plus 210, that gives me 320, which was our score together. Okay. All right. Alrighty. Now, I have another set of, I have one more equation problem, word problem, but I'm just going to let you guys copy it down here. Just copy all of this down here that I have here. You have a rectangular garden is fenced on all sides, with 256, feet of fencing. The garden is 8 feet longer than it's wide. Find the length and width of the garden to where you guys see that I have. The length, our length is equal W plus 8, okay? Because we need to find our width. So you have W plus 8 plus W plus 8. You got to do it 2 times because we're doing it on all sides. It says all sides, okay? And that gets me 256 when I do this, okay? Now, as you can see here, and well, I'm explaining it, so I might as well continue on. You see I got underlined in green the W's. Well, how many W's do I have? I have 4. So you're going to bring that down. You have 4W plus, then I have 8 and 8, which gives me 16. So 4W plus 16 gets me 256. Now, this is in the format of y equals mx plus b? Yes, so we could go ahead and solve it. So what do I need to do to get 4W by itself? Subtract 16 on both sides. So you're going to bring down your 4W. 16 minus 16 gives me 0. Mark it out. So you have 4W equals 256 minus 16 gets me 240. Then I need to get W by itself, this variable. So I had to subtract 4 on both sides. Going to have to subtract 4 on both sides. Now 4W divided by 4 gets me 1. So I automatically, exit out. So W equals, then you have 240 divided by 4 gets me 60. This is 60 foot here, you guys. 60 feet, excuse me. Now, I'm not done because this is my width. We already found our width, but I need to find the length as well. So if I come over to here, as I have it right here, this is our formula here of what we did here. So into here, our W, which is what? Our W is 60. So I need to plug that in to where W is at our variable. So you have length L equals 60 plus 8. Well, 60 plus 8 equals what? 68. So that is our length. Okay. That is our length. And we are finished with these notes here. Okay. So copy this down. I'm going to stop share now. Oops. I'm going to stop the share now. Hopefully you guys copy all this down. Now I have one more final video into our other lesson, which is equations with parentheses. So let's do that now. Let me exit out this. And find that video. Okay, equations with parentheses. Well, equations with parentheses. Here we go here. Pay attention. Continue having your notes. This is the last thing that I am covering. If this will pop up. All right, here we go. So we're doing the distributive property with this, okay? This is 6 minutes long. I didn't start yet. Hopefully he just only do, yes, okay. So I want you guys to watch this and pay attention. I'm not going to stop it. I'm not going to stop this. I'm just going to let it play all through. So pay attention to this here, solving equations with the distributive property. And I also have some notes on that as well. With the equations with the distributive property. So I will have those notes out for our next lesson that we will be doing. So pay attention to this here.
we have the equation negative 9 minus this whole expression, 9x minus 6. This whole thing is being subtracted from negative 9 is equal to 3 times this whole expression, 4x plus 6. Now, a good place to start is to just get rid of these parentheses. And the best way to get rid of these parentheses is to kind of multiply them out. This has a negative 1. You just see a minus here, but it's really the same thing as having a negative 1 times this quantity. And here you have a 3 times this quantity. So let's multiply it out using the distributive property. So the left-hand side of our equation, we have our negative 9. And then we want to multiply the negative 1 times each of these terms. So negative 1 times 9x is negative 9x. And then negative 1 times negative 6 is plus 6, or positive 6. And then that is going to be equal to, let's distribute the 3. 3 times 4x is 12x. And then 3 times 6 is 18. 3 times 6 is 18. Now what we want to do, let's combine our constant terms if we can. We have a negative 9 and a 6 here. On this side, we've combined all of our like terms. We can't combine a 12x and an 18. So let's combine this. So let's combine the negative 9 and the 6, our two constant terms on the left-hand side of the equation. So we're going to have this negative 9x. So we're going to have negative 9x plus, let's see, we have a negative 9 and then plus 6. So negative 9 plus 6 is negative 3. So we're going to have a negative 9x, and then we have a negative 3. So minus 3 right here. That's the negative 9 plus the 6. And that is equal to 12x plus 18. Now we want to group all of the x terms on one side of the equation and all of the constant terms, the negative 3 and the positive 18 on the other side. I like to always have my x terms on the left-hand side if I can. You don't have to have them on the left, so let's do that. So if I want all my x terms on the left, I have to get rid of this 12x from the right. And the best way to do that is to subtract 12x from both sides of the equation. So let me subtract 12x from the right and subtract 12x from the left. Now, on the left-hand side, I have negative 9x minus 12x. So negative 9 minus 12, that's negative 21, negative 21x minus 3 is equal to 12x minus 12x. Well, that's just nothing. That's 0. So I could write a 0 here, but I don't have to write anything. That was the whole point of subtracting the 12x from the left-hand side. And that is going to be equal to, so on the right-hand side, we just are left with an 18. We are just left with that 18 here. These guys canceled out. Now, let's get rid of this negative 3 from the left-hand side. So on the left-hand side, we only have x terms. And on the right-hand side, we only have constant terms. So the best way to cancel out a negative 3 is to add 3. So it cancels out to 0. So we're going to add 3 to the left. Let's add 3 to the right. And we get the left-hand side of the equation. We have the negative 21x, no other x term to add or subtract here. So we have negative 21x. The negative 3 and the plus 3, or the positive 3, cancel out. That was the whole point. Equals, what's 18 plus 3? 18 plus 3 is 21. It's 21. So now we have negative 21x is equal to 21. And we want to solve for x. So if you have something times x and you just want it to be an x, let's divide by that something. And in this case, that something is negative 21. So let's divide both sides of this equation by negative 21. Divide both sides by negative 21. The left-hand side, negative 21 divided by negative 21, you're just left with an x. That was the whole point behind dividing by negative 21.
Correct.
And we get x is equal to, what's 21 divided by negative 21? Well, that's just negative 1. Right? You have the positive version divided by the negative version of itself, so it's just negative 1.
I said that I was not going to do this, but I had to point this out again. Positive answer, a positive number divided by a negative number gets me a negative number. It does not give me a positive answer. It gets me a negative answer. As with the same thing as when you're adding. Positive plus a negative is a negative. Positive times negative gets me a negative. Positive divided by a negative gets me negative. Either way, you're going to get a negative answer. It's not going to be positive. Okay? I just want to point that out to you guys to refresh your memory. And also, a positive plus a positive is positive. Negative times negative is a positive, not a negative, not a negative. Okay? So please remember that. Please remember that. I can't stress this enough because if you don't remember that, then when you see something like this, you're probably going to say, well, oh, so 21 divided by negative 21, that's positive 1. No, it's not. No, it's not, because when you check it, because he's going to check his work, and if he had did a positive 1, for an example, his answer when he checked back his work, it is going to be wrong. It is going to give him another number, which means he has did something wrong. So he has to go back into this problem that he did and redo it again. Look back into it. If he had did it that way, or if you had did it that way, you have to go back and check your work. Okay? So I'm going to stop here because that is your answer, and he is going to check his work, but you guys should know how to do it by now. So I'm going to stop the share now. Hopefully you copy this down. If not, then you can go back. So I'm stopping the share now. Stopping the share now. There we go. So I hope you guys enjoy my lesson. We are still going to be dealing with, hold on, let me pull up my schedule real quickly, you guys, real quickly. Right in front of my face. We're still going to be dealing with, we're still dealing with equations, you guys. So the next lesson, which will be reviewed, we're going to be reviewing everything. Well, with this lesson here, the equation part, we're going to be reviewing that the next time. And then right after the review, I'm hopping right into a new lesson, which is numbers of solutions to equations. And I'm going to show you guys an example of that, and also how to create an equation with no solutions and infinitely many solutions. Oh, doesn't that sound fun? Yes, it sounds fun. Yes, it sounds fun. So thank you guys for tuning in with my lesson, not only with my lesson, also with Andrew's lesson as well. Let me fix myself because I am okay. So thank you guys so much for tuning in with my lesson, not only with my lesson, but with Andrew's lesson as well, whatever he taught the 6th graders and you guys about, because I don't know, because now we are pre-recording these sessions now. We're not, I mean, we're still doing this on Zoom, you guys, but we are showing you guys the pre-recorded lessons that we are doing on our own. We're not doing it together anymore, but we're still hopping on to Zoom together, and we are showing you guys our lessons. We are still, introducing, into the week's lesson, and then we're going to show you guys our lessons that we have recorded in advance, and then ended it off with our motto, which we should change it. Well, our new motto will be same grind but a different lesson. I'm taking off. I don't know about him, but I'm taking off the same time because we don't come on here at the exact same time with our lessons. So it's now same grind, but a different lesson. Okay, so thank you guys for tuning in with our lesson. So I'm ending it off because first is Andrew, and then with me. That is how it's going to be for now on. He's doing 6th grade, I'm doing 8th grade. So I'm going to end it off here. So thank you guys so much for tuning in, and we will see you guys back next time for we will both, me and Andrew, will see you guys back next time with a new math virtual learning session from us. So until you guys, take care of yourself, be blessed, wear your mask, social distance, and please wash your hands. And have a great and fantastic rest of your day. Goodbye, everyone.